Okay, so today I'm going to be running you through AI gateways, and I'm not gatekeeping any secrets, and if you don't like that joke, they're not going to get better. My background is in building AI infrastructure, which I do at DoubleWord, and I'm going to let you in of some of the learnings I've found in the last couple of years. So about me, I'm a member of technical staff, which really means everything and nothing at the same time. I build resilient AI platforms, and in my spare time, I like obsessing about coffee and wrestling people. So, and a very former owner of a mustache, sadly. It's still a bit sore. So what I'm going to run you through today is we're going to establish why you need an AI gateway, and then we're going to look at building it from the ground up. Some of the insights and some of the mindset we had at DoubleWord, and hopefully that can relate if you're going to be using AI, want a gateway, or if you're just building products in general, it might just be interesting. So this is going to be the summary of the talk, basically. So if you don't want to watch it, just read this. Basically, you need a single place to manage your AI's usage. Being fast means doing as little possible when it comes to a gateway. Features can be built on top of this ethos and can be executed asynchronously, and I'll go over that. And your LLMs will betray you, and expect it and prepare is my best advice. So first, why do you need a gateway? So we're going to set the scene. AI is everywhere. To name a few, it's application use case. We're going from chatbots, developer productivity, like Cursor, Copilot, report generation, summarization, document processing, you name it. The list can go on. But this is all great in theory, but our businesses are actually using it. And I've pulled up this report from McKinsey that said they do. 88% of businesses report regular AI use across at least one business function. Most people are scaling between 1 and 2. And you can see on the graph, as we trend, the percentage of people running up to like 4 or 5 is increasing. And I'd expect in the next couple of years, it to more look like the 1 or 2 functions. So basically, organizations, and the summary of this report, I'll share the slides and you can look at this yourself, is basically organizations are at the point where they've found value from AI, but they're looking to scale. And this is the problem you face when you start to scale AI. So the genie's out of the bottle. It's not going back in. 6 months ago, it was pretty easy to manage. There was one frontier model, which was ChatGPT, or to a year ago, and you had one team experimenting with it. Use cases weren't very mature, but roll through today. This is the case in a lot of enterprises I talk to. You've got 12 different teams, 4 different models being used across different providers, hundreds of API keys flashing around on people's notes and written down on the wall. Like it's a nightmare. The best-in-class model changes every month, whether it be Google, Anthropic, open source models like DeepSeek, Kimi, Qwen. Like it's hard to keep up. Like whoever's in charge of this, whether it's your IT, your DevOps, your CTO, like insert that person there, they're not keeping up with these use cases, and they have a choice of either to stop and slow their application builders or just let them run free. And hopefully this is like painted the picture that you need some accountability, and you need, at the moment the business is footing the bill for everything with nobody to blame, basically. So what I propose, and what I think is a good attempt at solving this problem, is you need an architectural lasso, I like to call it. You need a single layer that gives you control and a uniform interface to all your AI endpoints. A single place for doing cost and budgeting, not spread across providers, not spread across, especially if you're self-hosting models, like basically just spreadsheets and tracking and trust. You need a single place for authorization. You need to make sure people can quickly get access and aren't slowed down by that and are securely getting access, and you need a way to audit it. And you need a reliable foundation, basically in summary, for your application builders to move on from. Your application teams don't want to be weighed down with sorting out their AI access. You want to free them up to do their jobs. So that's why you need a gateway. And I'm going to take you inside how we built the DoubleWord control layer, which for short is called DoubleWord. Firstly, I want to set the scene. You need to be fast. So essentially, you're becoming a reverse proxy. And to be fast means to do as little as possible to get in the way of requests. You're not doing any special processing, like you're just sitting and enabling access to downstream processes. So doing as little as possible is the ideal to be as fast as possible. So if you introduce friction, people will stop using it. Friction will kill your application builders and they won't want to use it, and then you'll be back to square one, where they'll just go back to using their distributed providers, or they won't even use it at all. So how do you achieve speed? So here is some proof, basically, that what I'm saying is true. This is benchmarks of running 100 concurrent users against the DoubleWord gateway, compared to some open source competitors. And I'm going to talk you through why our numbers are so much better than the other competitors. There's nothing secret about it. It's just simple choices that enable you to not get in the way of the request. And it basically boils down with correct language choice, not putting database queries in the hot path of requests, and no request unpacking. So the first choice is what language to build the gateway in. Firstly, there's a top echelon, I would argue, of languages which are built for this low latency use case. They range from like C, C++, Rust, Go. You can pick any of them. Our preference was to use Rust, which sort of ties into a resilience benefit we saw from it, which I'll loop back to later. It's best in class compiler, arguably as good as C or C++, just a little bit slower, I think, technically on this benchmark. And no garbage collection due to its strict memory safety, which really helps its latency. So the second point, don't get in the way. So don't make life harder than it needs to be. Don't make database queries in your request hot path. Essentially, everything should be in memory. If you make database calls as requests coming in, then you are going to absolutely kill your P90/99 requests, which are just like your longest requests. Because although you might have a perfectly tuned database to start, it won't scale. And at some point, some queries are going to be slow, and you're going to absolutely nuke some of your requests. Databases are persistent stores, and they should be treated as such. They're not hot caches. And then another factor, particularly of AI gateways, a common place is to deserialize the requests, which is a bit unnecessary. It's not the biggest factor, but it's just a bit of free pennies on the floor you can pick up when building a gateway. You don't need to unpack the request. Serialization adds latency overhead, especially as you start to get into the larger requests. You can lazily search the request for what you need, which is essentially the authorization header, the path of the request, and then you can lazily find the model key you need to rewrite. So starting from this, we've basically got a very simple reverse proxy, I would argue, and it's going to be really fast. So how do we build features upon this that are useful for our application builders without compromising the ethos of what we just stated? So the first thing is access control. So who gets in? So my first bit of advice would be that simplicity is your friend. The more complicated you make your security, the more likelihood there will be loopholes in it, and there'll be headaches down the road. Your easiest answer is just don't become an identity provider. Just be responsible for authorization. Authentication is more or less like a pretty saturated market and solved in most businesses. They already pay for really good solutions and people who spend their entire job doing it. And quite a lot of them have a strong preference for you to integrate rather than have your own identities. So you're really saving yourself and customers headaches. So yeah, worry entirely about authorization and integrate with authentication providers. So dodging responsibility is good sometimes. There are many open source methods for connecting to identity providers, whether it be SAML, WS Federation, OIDC. We chose OIDC because we saw a lot of like businesses, especially people not weighed down by backwards compatibility with SAML, orientating towards it and used OAuth proxy. But it's essentially a cut and dry solution. There's a lot of guides online on how to set this up, and it saves you a lot of headaches. just one final thing is just, for the love of God, don't dedupe on people's emails because they change their emails in authentication and then it breaks your system, please. The amount of companies that do that, it's semi-crazy. Okay, so how do we actually get the authorization into our gateway? So we've got essentially a reverse proxy that's just forwarding on requests to AI providers. How do we keep the ethos of not getting in the way of the request, but check whether the user can make the query they are asking to make? So no database queries in the hot path, but we can do these database queries asynchronously. We asynchronously load the config from the database, and we can trigger it based on changes and also based on time. And you can set that config to dedupe to make sure you're not overloading unnecessarily. And then you can have a really simple system of just string matching against a set of API keys that are valid per model. And those are compiled asynchronously from your database with your management UI. And one of the nice things of using Rust is you can do this completely asynchronously with zero downtime by having writing to a file that from a process that watches the database triggers, and then the actual proxy written in Rust can communicate the file changes via Rust threads with its thread safety and memory safety. So you don't have to worry about restarting the server to get refreshing new config. Stay generic. So I think just my overarching opinion on access control is just simplicity is your friend. And this is also true for authorization. RBAC can be a minefield if you make it. I think too early people orientate towards application friendliness and apply too complicated technical hierarchies to their authorization. Essentially, all you need is to map many models to many users. And to do that, you just need an abstraction, which we've called groups. So groups, you can have many models that belong to a single group, and then you can have many users that belong to the single group. So the group is the bridging between your many-to-many relationship between models and users. And then your groups become application specific. So it's essentially like a UI wrapper. So under the hood, it's technically the same solution. If it's a team, an organization, a group of individuals, you don't need different hierarchical structures in your backend. You just use groups, and they're wrapped up in the UI differently. So yeah, and the benefit of this is you can also source these groups from your identity provider, which is also a very cool feature you can offer to more established enterprise users with big DevOps and IT departments. That tends to make them smile when you say that on the call. So yeah, credit abstraction. This could be its own talk. So a lot of the things I'm going to skate over, it could be their own talk. But basically, how do you add in some sort of budget, and how do you do that access authorization? I've said we don't want to add extra complexity. We added a little bit of processing in the proxy to actually look up this API key list and verify the authorization. And we don't want to add any more, and we don't want to add an extra database query. So we just add it to the asynchronous database query that's already happening. And what we do is we just omit API keys that are from users with invalid balances. This gives you the authorization section. People who don't have access to models and don't have enough money to pay for those models aren't allowed to send requests to them, but it leaves a little bit lacking on the user side because they don't immediately know why they're getting blocked from the request, because the API key just isn't there and there's no context about why it's not there. So to do this, we give them more context by contextualizing bad requests. So we stay out the happy path, which is authorized requests still go immediately to your downstream service, which reply as fast as possible. But to unauthorized requests, which are already really quick, you will do an enrichment middleware, which will do a database request to check why the user was unauthorized, to check it was a balance problem or it was an access problem, and then reply accordingly with a 403 for access, 402 for balance. And that way, you're not adding any latency by doing a database check on every request. That's the furthest thing we want to do, and you're only adding it to the 403s, which are super quick anyway, because they've only gone to the proxy and back, so you don't really care about making those slower, because they're bad requests. The happy paths left intact. Okay, so similarly, I'm going to whistle stop through monitoring, and how you add monitoring without compromising the speed requirements. And essentially, it's the same solution. It's asynchronously do the work and stay out the hot path of the request. So you can see here, similarly, there's a middleware that starts an asynchronous task in Rust, which basically summarizes the responses from your AI, and then it will just dump it to your database. It's sort of an interesting point why we choose to dump it to your own database, like the application database, rather than using something like Prometheus or OTel. I think our preference is for anything that needs to be, so there is a UI that goes alongside this control layer, which gives you metrics and visibility. Anything that needs, like a UI that needs data, we think is best held in a local database that's application specific and not in a distributed monitoring solution. That's purely because we don't want to tie ourselves in and couple ourselves to always running that solution, and that means that it's a whole product in and of itself, and it can be deployed by itself, and it doesn't have any requirements. But we also do integrate with Prometheus and OTel, and this is the point where it does. So it does 3 sections of writing locally to the database about the request metadata, publishing open telemetry metrics, publishing Prometheus metrics. So it doesn't matter if you're running it as it's binary on itself, whether you're running it in a distributed Kubernetes setup, whether you've got all the bells and whistles and you want your DevOps team wants to view all your data in a singularized place, this will let you do that. So reliability. So I think this is often a missed focus, especially with the state of the industry currently. People are just rushing to find value, and systems haven't been up long enough for this really to be a distinguishing factor, but this was the second half of our language choice, and it came down to reliability. You want as little surprises as possible, and we would argue that Rust gives you that advantage of its tight compiler and memory safety, means that there's little to no runtime panics, and mean that what you declaratively write, when you couple it with tight unit testing, is what's going to happen in real time. And yeah, the complaint I often hear is about the steep learning curve of doing Rust, but I think with AI copilots now, that's sort of taken away. I don't think people can complain about that anymore. So yeah, be invisible. And the second part of reliability is, even if you're reliable, your proxy's reliable, your downstream systems are gonna fail. So you need protocols to recover in those cases. Especially LLMs, they tend to be very flaky. So no matter how good you are, you're gonna have to deal with lost network calls, providers, availability zones going down, regions going down, different data centers going down, Cloudflare going down, AWS, if anyone has dealt with those headaches recently. So what you can have is fallbacks that span different regions, span different providers. You could have policies that mean that your generative request will default to OpenAI, but if it fails, it will then send it to Anthropic. You can set your own policies. If you have self-hosted clusters, you can go to third parties when your self-hosted clusters are down. It's sort of up to you. And then rate limits, retries, I think are important, especially at scale. It's not something too many people encounter at the moment because of just the volume of requests that are going through these models. You don't tend to get transient issues that you do at like really high scales of just requests getting dropped, networking issues, unpredicted issues that would just be fine on retries. So I think just a light, simple thing would just be a retry. And rate limits to protect denial of service attacks. These are especially important for self-hosted clusters because you tend to have very little vulnerabilities with that. So you can't leave a script run in, for instance, and blow up a 5K budget on Anthropic in an hour, or you can't like saturate your entire self-hosted LLM and ruin everyone else's day in your company. Yeah, and all of these things would have to be implemented in your application's code n times across every one of your use cases. So, it also saves you a lot of code having a centralized gateway. So, that's pretty much it. Yeah, this is the run through of what we've been through. I've argued that you need a single place to manage and see your AI usage. Like, being fast, I think, means doing as little as possible in the hot path of your requests, and you can build features on top of that limitation and still provide a great LLM, great gateway, in my opinion. And your LLM will betray you, so have features to prepare accordingly. And lastly, everything I've talked about is completely open source. Our gateway is is called the control layer. If you scan that QR code, it'll take you to the GitHub. If you're using AI in any sort of sense and don't have a gateway running, I would recommend you do. And if you want to try ours out, try our competitors out, please do. Open the issues, give us feedback, anything. Give us a star, please. Thank you. Any questions?